Hello students, we have just completed the chapter electricity and now we are starting your chapter magnetic effects of electric current. This chapter is also based on electricity. We have seen many electrical appliances that use electricity and convert that electrical energy into mechanical energy, like a fan. Fan sets into motion when we power it on. That means it uses electricity and convert that electricity into motion. And also if we talk about hydroelectricity, we know that water is used to move big turbines and the rotation of these turbines produces electricity. But why? So the reason behind all this is whenever electric current is flowing through a wire, it produces magnetic wave. Again I am saying, whenever electric current is flowing through a wire, it produces a magnetic effect. And we will study about this magnetic effect in this chapter. So let's start. We will start by studying about the magnetic field of a bar magnet. So what a magnetic field is? Magnetic field is a region around a magnet within which the force of the magnet can be experienced. Again, magnetic field is a region around the magnet within which we can experience the force of the magnet. So magnetic field always emerges from the north pole of the magnet and goes to the south pole of the magnet, outside the magnet. Like we have a bar magnet here and the magnetic field will come out of the north pole and will end, or not end actually, will go to the south pole, outside the magnet. And inside the magnet it goes from south pole to north pole. That is, it makes a complete loop. Outside the magnet it is going from north pole to the south pole, and inside the magnet it is going from south pole to north pole. The strength of the magnetic field is determined by the closeness of the field lines. That means if the magnetic field lines are crowded, it will have more force, it will exert more force, or we can say the strength at that point, the strength of the magnet at that point will be more. And if the magnetic field lines are farther away, or you can say they are less crowded, it will have a weak force. So we can say the strength of the magnetic field is determined by the closeness of the field lines. If they are closer, if they are denser, that means at that point the force is high, the force is larger. And if they are not crowded, that means at that point they are weak. And if a magnetic compass is brought near a magnet, it always points to the direction of magnetic field lines. That means if we bring a magnetic compass here and put it here, the needle of the compass will point in this direction, that is, in the direction of the magnetic field line. And also magnetic field lines never intersect each other, because if they do so and we brought a compass, the compass has to show two directions at the same time, which is illogical. So magnetic field lines never intersect each other. Again I am repeating all this. This is the magnetic field lines of a bar magnet. If we throw iron filling on a bar magnet, the iron fillings will arrange themselves in this shape. That is, they will show us the field lines. So, magnetic field lines always emerge from the north pole of the magnet and goes to the south pole of the magnet, outside the magnet, and inside the magnet they go from the south pole to the north pole. And secondly, the most important thing, they never intersect each other. And again, one more thing, they form a complete loop. Outside the magnet they are going from north pole to the south pole, and inside the magnet they are going from south pole to north pole, and again outside from north pole to south pole. That is, they completed loop. So this was all about magnetic field lines. Thank you.